All right, the prisms, the right square, rectangular, triangle, pentagonal. Gonna hold off on the obliques for now. The shapes that we're interested in are going to be pretty much the same as the first solids that we did, the polyhedra, except that the sides and a square would denote that the bottom face in this case is the same dimension, but the top is the height is a different dimension. And then the rectangular, all of the faces, the opposite faces would be the same, but the faces don't necessarily need to all be equal. The right triangular, right pentagonal, pretty much any shape. A polygon is going to fall into the three or more. So 3 sides is our triangle, 4 sides is our square, 5 sides, 6 sides, 7 sides, all the way up to you get enough that it starts to look like a circle. Um, so we pretty much did the right rectangular, uh, the pyramid, and if we do the truncated, we could go back to our beginning, and then we'll get to the cylinders and to the cone. So let's stay with the simple ones first, and then we'll get a little more complicated as we go. All right, so I'm going to hide my two starters, and I'm just going to go into the bodies and hide those two. All right, so the right square, and we'll just pick a point front plane. The intention is that these will always be square on the base, and the height might adjust. So let's go 50. And if I hit escape, that will take me out of the dimension. And in that case, I managed to select the midpoint. All right, so I want to select, hold down the control button, basically just selecting anywhere else will clear it, and then select the line, hold down the control button, watch for that midpoint, and then this time I'm going to use the pop-up to make equal. And we can go right into the features, extrude boss base, and it kind of flipped around. Yeah, let's go that way. And then whatever length you want to make it. If you drag the arrow, and this is not my favorite technique because it becomes a time consumer. And if you are in inches, it also goes down to the fractional. I guess it depends on the units that we're telling it. But as we get, as I kind of search, I can get to 50 millimeters. Oops, missed it. All right, so I'm at 50 millimeters. Most of the time, I will just draw, take the sketch, extrude it out, and type in the value, and then we want to accept it. All right, so that becomes a little bit larger. 50 millimeters, and did I manage to make that a cube? I can double check real quick. So there's my sketch. There's my dimension. So the dimension line, let's do that again, double clicking on the feature. The dimension line that's in blue is the extrusion, and the dimension line that is in black is from the sketch. So if I double click on that and make that 100, then I have to rebuild it so that it will update. All right, so that gives me the square. Now, if I wanted to change this over, I can edit the sketch, and I need to find that relation, that equal relation, and delete it. All right, so if I go to add a dimension while that equal is in place, it's going to show me that driving driven warning. And then instead of having a rectangular, I will have to still go ahead and remove that relation and add in a dimension or change the dimension over. All right, so square equals sides. and there's nothing wrong if I wanted to go back to the square once I have the dimension and rebuild of making the two dimensions if I'm not sure. If my design intent is I really want this to always be square, then I can make those equal. All right, so let's hide that one. We'll go, let's go to the right plane on this one so we get some interesting shapes. We did the right triangular already, but let's go ahead and take a look. So we have the three sides, and we have a couple of things that we need to do for the dimensions. So previously I dimensioned the inscribed circle. The circumscribed circle would touch on the outer points if we pick that as our parameter. If I made this 100, and again, it kind of shifted through the points, and I want to make that horizontal. All right, so my selection criteria is usually going to be the perimeter, a line, a circle, and the polygons are kind of a special case, so have to see what I'm telling it to do there, but you kind of see how that shifts and adjusts the geometry. So we're going to extrude that out some distance and hit OK. All right, so that gives us our right rectangular. And then let's see what we can do in that sketch. So I want to edit the sketch. All right, and sometimes, nope, I was thinking of the pattern. I was going to say we could look for an instance count, but we're not going to get one here. So let's just do the pentagonal on the top plane. Go in, tell it we want 5 sides. This time I'm going to tell it to do the circumscribed circle so we can see the difference. And from the origin, and then you see that the construction circle is through the points on the outside. I can put the dimensions. We don't really have across the flats here. I could go across an edge. All right, so if I went across the edge, then that would give me that flat. If it was a hexagon, then I could go from face to face, and then any odd number, which probably is one of the reasons that our wrench sets are set up for the hexagons. But anyway, we can go across the flats. Here I could go from the point to the flat. And if I hit escape on the keyboard and select one of the faces, then I'm going to make that horizontal. We go into the features, extrude boss base, and depending on which way I want it to go, I'm going to get the desired result. All right, and then pretty much we already did the base pyramid. Since I didn't make it all the sides equal to be the tetrahedron, really I was doing the right pyramid. All right, so let's go with the cylinder, the cone, and the sphere. So I can hide that one. Front plane, sketch, draw a circle. So let's see what happens if I don't put a dimension on this. Let's go back into the features. We'll do the extrude. That gives me the shape. And one of the things that I will see is my sketch is underdefined. All right, so if I'm in the instant 3D and I pick on that face and that dimension is not there, let's see which one, there we go. We can stretch or shrink it, which is sometimes handy, but most of the time it's not a desired result. So that's one of the reasons why when we went through the options, I have you turn off the instant 3D. The cone then, we're not going to be the same. We're going to have to switch over to a revolve. So this would be a good time to also look at what happens when we do a cylinder as a revolve. So I often mention that, let's see, let's go ahead and do the rectangle. Opened up a sketch on the front plane. We'll do the rectangle. If I look at a part and I think, oh, I'm going to make this on a lathe, then it's probably going to be a revolve. All right, so 100 millimeters. I don't have anything to do the diameter, so I'm giving it a radial. Let's go 10. And I want to pick an axis. So these will not self-intersect when I go to revolve, so it doesn't really matter which one I pick, but it is going to affect the resulting geometry. So if I go that way, I have a cylinder. If I go that way, I have a cylinder. It just happens that the cylinder looks more like a disc. And I could pick that one and it goes the other way. It just depends on how we want the resulting geometry to be aligned. All right, so that would be my second cylinder, but notice we're going from a boss to revolve. Now there's times where, depending on the complexity of the geometry, building up multiple layers like a wedding cake is going to be way more complicated than dealing with one revolve. So I want to keep that that in mind, and I'm just kind of switching through the planes because we don't have to have anything in particular. And our cone then is going to be a triangle. Right, so I'll go back and we'll put the 50 in, we'll make that 100. And the cone is going to follow the same revolve base. And if I go that way, I get that cone. And if I select that line, I get that cone. All right, so they're both in the valid solutions, but is it the desired result? And last, we'll do the sphere. So the sphere could be drawn as a circle. The problem becomes that a circle will self-intersect itself. But if we use our contours and regions, so let's go back into the front plane on this one. If we use the contours and regions, I also need an axis for revolution, so I'm going to draw this line anyway. And we'll make this 100. I can go into the features, tell it to do a revolve base, the axis of revolution, and I don't get a preview. Now, if I went 180 degrees, still not really happy. All right, so notice that the selected contours popped up for me, and when I pick one of those, oh, it's also trying to do a thin feature, probably because of the contour. But notice that it will do the 360 degrees. The other one of interest would be if I make this an actual construction line. And this would give, so there's the line. This would give the self-intersecting geometry. Notice that 180, still finding the contour? No. 180 gives me the hemisphere. Okay, so either that updated or something, nope, there it is. Open, self-intersecting, or intersects the line. So if we go in, the construction line will still create a region, and then it will allow me to finish the sphere. All right, I'll hide one more time. Let's see, going through the cycle, our next one is the torus, which is kind of a donut, and then the ellipses. All right, so we're in the front plane. Whenever I'm doing a revolve that will have geometry outside of the center line, then I'm going to do vertical or horizontal, depending on which way, in infinite length. Infinite length just says I'm not ever going to run out of this construction line. And then depending on where I put the circle, and again, under defining it means that it's going to be free to move, and possibly free to move unexpectedly. And then we'll finish up with the ellipse. Is kind of a unique case. We could do it like I did the circle, but we have a partial ellipse, and then this also falls into the 3-point arc type, where if you have a process, we're going to pick the center. I'm going to pick the major diameter and then the minor diameter, but then because this is a partial, I need to draw the partial that I actually want. Now the ellipse is still going to be solved as 4 node points, and then the definition between those 4 node points. So the minor axis 100, and the major axis will be my axis of rotation, so let's just say 200. Now it did rotate, so there again, because oh, the line kind of got lost. I think I really want to do a Control Z there. And something definitely shifted between those two. I can't say that that was expected. So let's set that vertical. Oh, and then that one's, okay, so our best diagnostic tool is going to be to drag something and see what kind of strange things it does. I kind of expected that I was putting that at the midpoint, but I did not. All right, so bring my points back. Select, Control, select the points. Those would be horizontal, and I get it to go fully defined. Not overly intuitive as to the solution and what the error is there, but sometimes you're going to have to uh, pick things and try things and experiment and see what you get. All right, so the axis of revolution, and we get our egg shape. All right, so if I go in and I show all of these, I'll manage to turn it off, but if I show all of these, they will all intersect and do fun, strange things. And as I highlight over them, I'll be able to see where they fall into the overlap. But these always end up being kind of strange looking demonstrations when they're done. All right, so the obliques we'll deal with later, but this gives us a good sense of the types of geometry, and there's also some manufacturing challenges to these more complex shapes that we'll ultimately have to deal with.